Hello everyone. My name is Eleni Papanikolopoulou and I am an IS developer at Workable. Workable is an applicant tracking system that helps companies streamline their hiring process. And today I'm gonna talk to you about RxSwift unit testing. So first, let me guide you through the agenda of today's presentation. We're going to start by describing some basic concepts of RxSwift. Then we're going to see how we can implement a very simple signing up by using RxSwift. And finally, we're going to explore the different ways in which we can unit test our app. So, RxSwift. I guess everyone is familiar with the term. Either it's in the latest developer conference you have attended to, or you have actually used it in your projects. So RxSwift is basically the Swift implementation for Rx, and it follows the basic patterns and paradigms of reactive and functional programming. Some basic concepts are, first we have observables. So an observable is basically a sequence that emits elements asynchronously, and if you subscribe in that sequence, you will start receiving those elements, aka events. But what is an event? An event is basically the elements emitted by the observable sequence. So an event is an enumeration with three possible cases. A next case, which is the next element emitted by the sequence. An error case, which is emitted once the sequence fails with an error. And a completed case, which is emitted once the sequence terminates successfully. Then we have observers. Observers basically listen for the events. So an observer is actually a closure that is passed to observable and is executed once the sequence element is received. And we do that by using the subscribe operator. Then we have subjects. A subject is a special kind of observable that acts both as an observer and an observable, which means that it can both emit and receive events. And we have different kinds of subjects, such as a public subject, a behavior subject, a replay subject, and a variable. And in our example, we're going to use a public subject and a replay subject. The very basic difference is that once you subscribe on a public subject, you will start receiving the events after the subscriptions happen. Whereas if you subscribe on a replay subject, you will also receive the elements that have been emitted before the subscription happens. And this is called replaying of events. And a replay subject gets initialized with a buffer size, which corresponds to the number of events that it can replay. And then we have operators. Operators are used in order to transform, combine, or filter the events emitted before they reach their subscribers. And in RxSwift, there are different kinds of operators, and there are too many. One is impossible to know what each one of these does, unless you have actually used it. But there is a very cool app that comes to the rescue. It's called Rx Marbles, and you can download it from the App Store for free. And it also has a visual depiction of operators, so it's pretty useful. And then we have side effects. Side effects are chunks of code that are executed after an event is emitted. So we have side effects by calling the do-on operator. So we have the do-on next if we want to execute a closure after the event is emitted, the do-on error if we want to execute code on an error, and do-on completed if we want to execute code once the observable sequence is finished, is terminated. And then we have schedulers. Schedulers are used in order to force operators to do their work on specific queues. And again, we have different kinds of schedulers. And we very often use the main scheduler, especially when we want to do stuff in the UI and we want to be on the main thread. Finally, we have dispose bags. A dispose bag operates like a garbage collector, so we call it when we want to cancel the subscription on an observable. So an observable basically lives for as long as the dispose bag to which it is attached to lives within the app lifecycle. So now that we became a little bit wiser about RxSwift, we are ready to start implementing our app. So it's a very simple sign-in form that has an email text field and a password text field. And it also has validation for email and validation for a password. And if both email and passwords are correct, the sign-in button gets enabled. And once we click it and make the sign-in request, we get an alert with a success if the request is successful, or an alert with an error if the request is unsuccessful. So what is the architecture that we're going to use in order to implement our sign-in app? So it's basically the MVVM pattern. So we have the view controller, which has all the UI elements, and we have the view model. And the view controller feeds the view model with the events, and the view model, after doing some stuff, it constructs the outputs, which exposes as observables to the view controller, to which the view controller subscribes to in order to update the UI accordingly. So let's see the view model a little bit closer. So the view model takes several inputs. So it has an observable of the email typed by the user, an observable of the password typed by the user, and an observable of whether the sign button is clicked or not. And these constitute the inputs of the view model. And then the view model generates the outputs. So the output is an observable of type Boolean, which corresponds to whether the email type is correct or not. An observable of type Boolean of whether the password type is correct or not. An observable of whether the sign-in button is clicked or not. And an observable of the sign-in response. And these constitute the outputs of the view model. So what is the code that we need to write in order to implement our view model? First, we have the inputs. And as we said earlier, we have an observable of type string for the email, observable of type string for the password, and observable of type void for the sign-in button click. And the view model also constructs the outputs. So we have an observable of type Boolean of whether the email type is valid. Same for the password. Same for the sign-in button, and observable with the sign-in response. And the view model gets initialized with the sign-in API, which is of type sign-in API type, and we'll see after what this is, and a disposable. So in the configure method of our view model, the view model gets the input observables from the view controller, and we'll see later how the view controller constructs those inputs, and tries to generate the output observables. So it constructs the email is valid, and how does it do that? It gets the email text, which is an observable of type string, and it maps it to an observable of type Boolean, which corresponds to whether the email is correct according to a regex that we use. And it does that by using the map operator. And we do exactly the same for the password is valid observable. And here we create the sign-in button enabled observable. And we do that by combining the two before mentioned observables, and we return a result which is Boolean if both email and password are valid. And we see here that we use the start with operator with an initial value false. This is because when the sign-in screen first appears, we want the sign-in button to be disabled even though the user hasn't typed anything yet. And then we have the sign-in action. So let's see this piece of code a little bit more closely. We see here that we use three different operators: the combined latest operator, the unwrap, and the flatmap latest operator. So let's see what each one of these operators do. The combined latest operator combines the events from the input observables and creates a result by applying a function that we have specified inside the closure. The unwrap operator, which is part of the RxSwift extension and thus requires a different import, returns a sequence of non-optional elements. So what it basically does is that it filters out the events with nil values. And the flatmap latest operator combines the result of the latest events from observables A and B and flattens the results to a single observable. So by using those operators, we take those input observables, the email text, email is valid, the password text, password is valid, and sign in button tab. We make the validation and we return a result if both email is and passwords are valid. And then we do the sign-in action and return the sign-in response. And we do all of this stuff by using only these lines of code. So this is what I'd like to call Rx magic. So the sign-in API. So first we need to define a protocol which is called sign-in API type in order to be able to use it later on to mock the network layer in our class, in our test class, which has a sign-in function with sign-in details parameter and returns an observable sign-in response. And the sign-in response is a struct that contains token. And this is how we implement our sign-in method. Here we have assumed that we've created an HTTP client, which is a wrapper of a URL session that converts the request to observables. So we make this, we return the request as an observable with a sign-in response. So the sign-in view controller. It has the outlets for all the UI elements that we saw earlier. And in the view did load, we initialize our view model with a sign-in API and a dispose bug. And then the view controller constructs the inputs of the view model. And it does that by using this reactive extension on a text field, the .rx.text, which returns the text typed inside the text field as an event. And we filter out the events with empty strings. And RxSwift provides those reactive extensions for most UI elements, for text fields, buttons, switches, and so on. And we do that, same for the password and for the sign-in button. And we pass those input observables in the configure method of our view model. And what we also have to do is that we have to subscribe to the outputs of the view model. And we do that by using the bind operator, which is a special kind of subscription that also includes error handling. So with this line of code, we show or hide the error label. And we do the same for the password error label and for the sign-in button to be enabled or not. And we also subscribe to the sign-in observable, and we do that on the main scheduler because we show an alert with a successful message if the response is correct, and an alert with an error if we have an error. And this is all the code that we need to write in our view controller in order to implement all the functionality. So now we're ready to start writing our unit tests. We saw earlier that this is the architecture that we use. Now what we have to do for our unit test is that we have to fake the way the view controller feeds the input events to the view model, and then we just have to verify the events of the output observables. For our test, we're going to use Quick Enable. So Quick is a behavior-driven framework that in which we can write tests as simple structures, and Quick uses Enable as a mature framework. And with Quick Enable, tests as the expectations as expressed as expect something to happen or expect something to not happen. So this is how our test class looks like by using Quick Enable. In the before it, we have all the initialization code, and inside the context, we specify a condition that we want to apply, and inside the it closure, we have the expectation or the assertion. And before writing our test, we need to decide what we want to test. And what we want to test is, of course, the view model, because this is the class that has all the logic. We could also test the bindings that happen in the view controller, but we can do that on the secondary stage. And we need to mock the network layer. That's why we create a sign-in API fake that conforms to the sign-in API type protocol. And it has the same sign-in, the method sign-in has the main signature, of course. And here we have also a property, the sign-in called, which is Boolean, and gets a true value once we subscribe to the sign-in observable. And we also have a public subject with a sign-in response in order to be able to mock our response to our test as well. So, there are different ways in which we can write our unit tests, and the basic differentiating factor is the way we set the timeline of events. So, we can write our test by using a public subject, by using Rx blocking, by using a test scheduler, and by using marble syntax. Let's see how we can write our test by using public subject. So, in our test class, we have our subject under test, which is a sign-in view model. We have a sign-in API of type sign-in API fake and a disposable. And we have those public subjects that corresponds to the input observables in order to be able to use them to mock the input events. And we also have those properties that corresponds to the values of the events emitted from the output observables, which we're going to use later to make our sessions. So in the before each, we have a sign-in API of type sign-in API fake and a dispose back. And we initialize our sign-in view model with the sign-in API fake and the dispose back. And we initialize our input public subjects. And then we pass those public subjects in the configure method of view model as observables. And what we also do is that we subscribe to the output observables and store the values emitted by the events in the properties that we defined earlier. And we do that for the rest of our outputs. And we are ready to start writing our expectations. So here we expect to take a first event that the sign button should be disabled, which corresponds to the start with operator that we saw earlier. And in the before each inside context, we give a next event to the public subject to simulate that the user has typed an invalid email. And what we expect to happen is that we expect to get an event that the email that we just typed is invalid. And inside another context, we give a next event to the public subject as if the user has typed an invalid password. And we expect that to get an event that the password we just typed is false. And we also expect that the sign-in, since both email passwords are invalid, we expect the sign-in button to be disabled, to get an event that the sign-in button is disabled. And we continue on by giving a next events to simulate that the user has typed correct email and passwords. And we expect to get other events that the email that we just typed is correct and the password we just typed is correct and the sign-in button is enabled. And since both the sign-in button is enabled, we give a next event to simulate that we have typed the sign-in button. And we expect that the sign-in method is called. And we give a next event with a fake sign-in response. And we expect to get an event with the token that we just gave. And we're done. This is how we manage to unit test our view model by using a public subject. So let's see the pros and cons of this way. You see here the test class that there's a lot of nesting. But it's relatively easy to write and read. It doesn't require any special knowledge of the testing infrastructure of RxSwift. And we don't have to think the timeline of events right from the start and the expected events right from the start. We think about them as we write the nested contexts. But we saw that there's a lot of nesting, and we don't test when the events are emitted, only which events are emitted. And we will see later on how we can test the timing of the events as well. So let's try to write the same test by using our Rx blocking. Rx blocking is another framework that is provided by RxSwift and thus requires a different import. And Rx blocking, what it does, it basically blocks the current thread and waits for the sequence to complete. And that's an observable is converted to, we can access the results of the events of an observable in a synchronous way. And by using the two blocking operator, we convert a regular observable to a blocking observable. And by calling the toArray operator, we manage to get an array of the events emitted only if the sequence is completed. And the public subject doesn't work with RxBlocking, and there's a relevant GitHub issue about it. So here we need to use a replace subject. So in our test class, we have the same input and input observables, only here we use a replace subject instead of public subject. So we initialize those replace subjects with a buffer size 10. And we pass those input observables to the configure method of the view model as we did before. And this is how the assertion looks like by using RxBlocking. And you can see here that we use a try syntax because our toBlocking operator is throwable. And by using the toArray operator, we can get an array of events emitted and validate them. So this is how the tests look like now by using the RxBlocking. If you see a little bit closer, you will see that we have some additional uncompleted events. Because as we said earlier, the toBlocking will never give us results unless the observable sequence is completed. So let's see the pros and cons of this way. You can see here that again there's a lot of nesting. But it's also relatively easy to write and read. We just use the toBlocking operator on the observable, and you manage to get the events emitted by the specific observable. And again, we don't have to think the timeline of events right from the start and the expected events right from the start. We think them along the way. But we have additional completed events which do not correspond to the real case scenario. And we can't use a public subject, so this is a limitation we have with RxBlocking. And we do not test when the events are emitted once again, we test only which events are emitted. But we cannot use RxBlocking for non-terminating sequences. And also, we block the current thread, and our tests maybe take a little bit longer. So let's see how we can write our tests by using a test scheduler. A test scheduler is provided by RxTest, which also requires a different import. And we use a test scheduler in order to simplify the testing of time-based events. And a test scheduler enables us to create mock observables and mock observables. They are called testable observable and testable observer. And it enables us to record those events and validate them. And a test scheduler has a clock with a virtual time. And here I have to say that the virtual time doesn't correspond to actual time. So 10 in test scheduler doesn't correspond to 10 seconds or 10 minutes. And by using a test scheduler, we can use a testable observer. So the advantage of a testable observer is that it exposes an events element which we can use in order to validate our events. So we initialize the test scheduler with a virtual time 0. And then we use the scheduler to create the testable observer. And then we subscribe the output observable to that observer in order to be able to take the events emitted by those observables and validate them. So by using the events property of the observer, we get the events and we validate them. So in our before it's class, we initialize all the observers that corresponds to the output observables and should be of the same type. And we can schedule at virtual time 0 to subscribe those output observables to their corresponding observers. And then we can schedule at virtual time 0 to give the next event to trigger the next event of the public subject that they have typed an invalid email. And in the same way, we can schedule all of the input events. And we don't have to forget to run this line of code, because if the scheduler doesn't start, none of the above will happen. And this is how we can write our validation now by using the testable observer. we can take the event emitted from the output observable from the observer and validate it. So this is how our tests look like by using the observers. The rest of them. But here we can take it a step further. We can use also testable observable in order to replace the published subject and the replace subject that we used before. And this is how we use the scheduler to create a testable observable. And here you can see that we can also specify the time that we want those events to be emitted. And again, we pass this observable in the configure method of our model. So we do the same for all the input observables. And then we can even take it a step further, and we can specify an array of the expected events. And we specify the array of the expected events like this. Now, you can see that there is a correspondence in the time. So at virtual time 1, we typed an invalid email, and we expect to have an output event at the same time that the email that we just typed is not valid. And this is how we can test at the time as well. So this is all the expected events and the time that they are emitted. And this is how our sessions look like now. We have an array of events from the observer and validate them against an array of expected events. Now you can see that the validations here have been simplified a lot. So this is how our test class looks like now. You see that there is no nesting at all, but there is a lot of boilerplate initialization code. So what are the pros of this way? As we said, there is no nesting, and we have managed to simplify the assertions, and it's relatively easy to read, and it adds extra flexibility to test when the events are emitted as well. But as we said, there is a lot of boilerplate initialization code inside the before each. And we have to think the timeline of events right from the start and the expected events right from the start. And this maybe is simple for simpler flows, but maybe it's too complicated sometimes for more complex flows. So finally, let's see how we can write our unit test by using Marble syntax. Now, in Marble syntax, we use letters and values to mark events in structs, where the key is the name of the event and the value is the value of the event emitted. And we can use this syntax in order to specify the timeline of the event. Now, the horizontal dashes correspond to the virtual time, and the vertical dash corresponds to the observable sequence the observable sequence is completed. And we can return an observable sequence specified by timeline and values. So in our test class, we're going to have exactly the same properties as before, but we're going to initialize them in a different way. So by using the Marble syntax, we have the emails typed as a struct, and then we use the test scheduler to set the timeline of events. So after 3 in virtual time, we have an event called E1 that has a value of an invalid email. And then we can use this timeline in order to create a testable observable. You see here that we use this parse events and times, which is part of a test scheduler extension. So this is how we can initialize our input observables by using Marble syntax. And we can do the same for the output observables. Now, I know this seems very odd, especially if you haven't used Marble syntax before. It looks like hieroglyphs. And these are our expectations. They are exactly the same as before. we validate an array of events from the observer against the expected events. So let's see the pros and cons of this way. Again, there's no nesting, but there's a lot of initialization code as well. So there's no nesting, and we have flexibility to test when the events are emitted again. But it's really difficult to read and write. And we have to think the timeline of events right from the start and the expected events right from the start. Now, I know that most of you probably are confused because it's a lot to take in, especially at this time. But if you want to take something home from this presentation, it's this. If we use MVVM, the correct way to write our unit tests with RxSwift is to fake the input events and feed them to the view model, and then get the output events and validate them, and validate that they have correct values and they are emitted in the correct timing. And if you understand this, you can really have understood how we can write unit tests in RxSwift. So to sum up, there are different ways in which we can unit test a component, and each one has its pros and cons. And each one should select the method that suits your needs. So at some points, maybe an Rx blocking should be appropriate for simpler flows, but for more complex flows, you may find yourself needing a test scheduler. Or maybe at some point, you may find yourselves to combine those methods. So thank you, and this is the link to the GitHub repo that has all the code that I showed you before. Thank you.